Today I'm going to talk about a substance called glutathione. Glutathione is sold in supplement form, but is the supplemental form of glutathione of any use at all? I'll explain why as this video progresses. But let's first of all explain what is glutathione. Glutathione is one of the major uh, endogenous antioxidants. In other words, it's one of the primary built-in antioxidants found in the human body. There's a number of them. There's glutathione, there's superoxide dismutase, there's catalase. Glutathione is, they're all very important. And an important thing to know about these kind of built-in antioxidants of the body is they're thousands of times more powerful than any dietary antioxidant you could take. There's a problem with some of these endogenous antioxidants in that as you age, your body tends to produce less of them, and the less antioxidants produced in the body, the greater the rate of oxidant-related diseases, including cardiovascular disease, cancer, and aging. Glutathione itself is what they call a tripeptide. That means it's composed of 3 amino acids. The amino acids are glutamic acid, cysteine, and glycine. Of the 3, what they call the rate limiting or the most important amino acid needed for glutathione synthesis is cysteine. Cysteine is a sulfur-containing amino acid that is also a precursor for the production in the body of taurine, which is another important amino acid that I've discussed in previous videos. Glutathione, like as I said, it's found in every cell, and it's a major cellular antioxidant. Exercise, when you work out, you actually lower your glutathione content of cells. It's lowered. Of course, the body will compensate by producing more later, but it's important to note that when you work out, you actually stimulate the production of built-in antioxidants such as glutathione, because these built-in antioxidants are needed to protect the cells from all the intense amount or large amount of oxygen that you're taking in when you work out intensely. When you do aerobics, even when you work out with weights, you're breathing much harder. This oxygen that you're bringing in tends to cause oxidation reactions. The body reacts by upgrading the production of antioxidants. And this is one reason why a lot of scientists and researchers think that taking antioxidant supplements is actually a waste of time. And there's another reason I'll get to later, but the notion is that taking too many dietary antioxidants such as vitamin A and C and E will actually blunt the production of your built-in antioxidants such as glutathione, which are much more potent than the dietary antioxidants. That's kind of up in the air, though. Nobody really knows that. I don't think there's any real harm of taking dietary antioxidants, except at certain times, which again I'll get to later in this video. Glutathione can be absorbed in the intestines. If you take they have these oral glutathione supplements. And like I say, the glutathione supplements are just basically a tripeptide composed of the 3 amino acids, glutamic acid, cysteine, and glycine. The only problem with the, one of the many problems with the oral glutathione supplement is that it can be absorbed in the intestine, but it can't get into cells. In other words, it can't actually penetrate into cells. It has to first be converted into what they call cysteine. That is not the same as cysteine. Cysteine is spelled C-Y-S-T-I-N-E. 2 molecules of cysteine together form cysteine. It gets into a little complicated biochemistry. I don't want to get into that. But the point being that nearly all oral glutathione supplements are worthless. They're a waste of money. The best way, if you want to know the best way to actually boost glutathione synthesis, it's by ingesting a readily available cysteine source. Because as I say, cysteine is the rate-limiting amino acid for glutathione synthesis in the body. The best supplement for that is a supplement called N-acetylcysteine, or NAC. Some cysteine residues also exist in whey protein. In other words, whey protein has some cysteine in there, but and that can be converted to glutathione, but it's not as efficient as taking NAC. NAC basically is a direct precursor for glutathione synthesis, and glutathione is produced in the liver. Now, glutathione, even though oral glutathione can't enter the cells, it can enter the blood. As I say, it can be absorbed and it can enter the blood. And in the blood, it exerts antioxidant effects, and it's synergistic. This is interesting. In the blood, glutathione has a synergistic effect with citrulline. I've discussed citrulline in past videos. Citrulline is an amino acid that is known to, after oral ingestion, is converted in the kidneys into arginine. As soon as the arginine gets into the blood, it's converted to nitric oxide. So citrulline is a very good dietary precursor for nitric oxide production. But it turns out that if you take glutathione, or you take a precursor to glutathione, such as NAC, with the citrulline, it actually boosts the effectiveness of the citrulline in boosting nitric oxide. So NAC, or glutathione, is an indirect nitric oxide booster. And the reason for this is that nitric oxide is produced in various parts of the body, mainly, for example, the lining of blood vessels. However, nitric oxide only lasts for a couple of seconds, and after that, it's broken down. And the thing that causes it to be broken down is that it's rapidly oxidized. So if you take a source of oxidants, or precursor for glutathione, it actually kind of extends the life of nitric oxide, and it makes it work better. This is why a glutathione source such as NAC taken with citrulline will make citrulline more effective in boosting nitric oxide. Not many people know that. Now, in the liver, glutathione is particularly important because it acts as one of the main detoxifying enzymes in the liver. Glutathione participates in a process, and I'm not going to go into the explanation again. It's very technical. It's beyond the scope of this video, but the process is called conjugation, and it's one of the steps the liver takes to take, let's say, fat-soluble substances and convert them into water-soluble substances, so they can be easily excreted out of the body by the kidneys. They can be excreted by the kidneys. One of the things that glutathione does this with are anabolic steroids. Oral anabolic steroids, let's say the main problem with oral anabolic steroids, let's say one of the main problems is the fact that they build up in the liver. They resist liver breakdown. As a consequence, they tend to accumulate in the liver, and they'll cause a swelling of the liver. The swelling of the liver slows down the flow of bile, which is manufactured in the liver. This causes a situation called cholestasis. The cholestasis, if it proceeds, it can actually start to break down liver cells, and now you could eventually have severe liver problems. The glutathione, as long as you maintain high glutathione, it'll help to rid the liver of excess oral anabolic steroids. It doesn't make these steroids any less effective, but it can possibly prevent some of the toxic effects of steroids in the liver. Now, I'm going to have an article in an upcoming edition of my Applied Metabolics newsletter. I'm going to talk in depth about the effects of anabolic steroids in the liver. I'm going to have stuff in that article that's never been written anywhere except in very esoteric medical journals. This is coming up. This is a very useful article to anybody who uses any dose of oral anabolic steroids, because the effects of anabolic steroids are based on time and dosage. In other words, how much you take and how long you take it, that's another story. But getting back to glutathione, as I said, it's one of the main liver protectors. It helps to helps the liver rid the body of possibly toxic substances by helping to convert them into a water-soluble form, where they're then excreted by the kidneys out of the body. Glutathione, besides being available in supplements, it's also found in foods such as fruits and vegetables. 50% of the glutathione that people ingest are from fruits and vegetables, and another 25% comes from meat. Unfortunately, the amount of glutathione in these food sources is very small. The average person, even if you eat a good amount of these foods, you'll get maybe 100 milligrams of glutathione. And again, it's questionable whether this food-based glutathione even gets into the cells. It doesn't really contribute to the synthesis of glutathione in the body. That's what the studies have shown. Now, they have another form of some alternative medicine doctors often prescribe intravenous glutathione. Now, the ostensible reason for intravenous glutathione is because, as I said, there's problems with oral glutathione supplements because they can be absorbed, they get in the blood, but they don't get into cells. And for glutathione to be most effective, it has to be absorbed into cells. So the thinking is that intravenous glutathione bypasses the problem associated with oral glutathione supplements. The only problem with that is some studies show that even with the intravenous glutathione, as soon as that glutathione gets in the blood, it's again degraded into cysteine. So it doesn't retain its tripeptide structure. It's degraded. So the intravenous glutathione really doesn't have much more benefit than taking the oral glutathione supplements. That's kind of debatable because there's been some studies that showed, for example, there was a study done of an older runner who took certain doses of oral glutathione, and they tested him before and after. He showed significant increases in muscular endurance and lower fatigue after intravenous glutathione. Not sure how to explain that other than possibly the glutathione was the intravenous glutathione was converted into cysteine in the blood, then it might have been converted back into glutathione in cells. It's just a speculation on my part, but we do know that intravenous glutathione, when it gets in the blood, it's kind of degraded pretty fast. Now, there's an oral form of glutathione, and again, I'm not turning this into a commercial. There's a form of glutathione. It's a company. I don't know the company, but the product is called Cetria. They claim to use a proprietary form that allows oral glutathione to be absorbed. I'm very, very skeptical of this. The only research that's been done on this, as far as I know, has involved research that's been paid for by the company that sells this product. Even if it did work, even if it did increase glutathione content of cells, it's probably, I don't know the exact price. I would suspect it's probably about 5 or 6 or 7 times more expensive than NAC. NAC is N-acetylcysteine, which is inexpensive and which we know for a fact definitely boosts glutathione. I would stick with the NAC. I would not spend extra money on this product. The production of as I said earlier, the production of glutathione tends to decline with age, as do many things in the body. Trust me, I know. Anyway, at my age, I know. Studies show that older people have, interestingly, studies show that older people who have higher glutathione levels tend to be much healthier compared to older people that have lower glutathione production in the body. And the older people that have optimal glutathione production also tend to show far less incidences of degenerative brain disease, including Parkinson's disease and Alzheimer's disease, because there's an oxidant component to those diseases. In fact, if you provide NAC, again, N-acetylcysteine, and the dose would be about 300 milligrams twice a day, 600 milligrams. You can take up to 1,200 milligrams if you want, but 600 is usually enough. If you supply NAC to older people, their glutathione production becomes just as efficient as a younger person. So NAC is extremely effective in that particular instance. One reason why older people tend to be lagging in glutathione production is because they don't eat enough protein. Remember, glutathione is just a combination of 3 amino acids bonded together. And if you don't ingest those amino acids in food, then you're not going to produce sufficient glutathione. So a large, major reason why older people tend to have lower glutathione production, and why other older people do have good glutathione production, is because the good people that have the good production are probably eating enough protein compared to the people that don't produce enough glutathione, who are not eating enough protein. There's another antioxidant also available in supplement form. It's called alpha-lipoic acid. This can also boost glutathione synthesis in the body. It's a complicated process, and I'm not going to go into the description here. It's pointless. It's only really of interest to people involved in biochemistry research. But the point to know is that alpha-lipoic acid helps in the synthesis of glutathione, and it also helps in the regeneration of glutathione when it becomes oxidized or reduced. As noted earlier, you know, well, there's other substances, other antioxidants that'll also help to boost nitric oxide again because they're antioxidant action. That includes cocoa polyphenols, pomegranate, and garlic. So, and one thing I want to add is that NAC is probably the number one supplement for boosting glutathione. And again, I would suggest the dose is 300 milligrams twice a day, 600 milligrams. Interestingly enough, taking NAC, there's some studies that show that it also helps to prevent the flu, influenza, which is kind of an interesting. I'm not sure why it does that, but a couple of studies have shown that. On the other hand, there's other studies that show that ingesting, remember, NAC, because of its conversion to into glutathione, it's a potent antioxidant. And some studies suggest that taking NAC immediately after a workout will tend to blunt some of the benefits induced by working out, such as increased mitochondria formation, decreased insulin resistance. A lot of this is caused by the release of what they call reactive oxygen species, or better known as free radicals, during training. Free radicals used to be thought of as a very bad thing, but then now they know that a brief small release after a workout, they act as signaling factors, and they're actually very beneficial. If you take antioxidants such as NAC, vitamin C, vitamin E right after a workout, you'll actually blunt the release of these free radicals, and you'll kind of interfere with some of the health benefits of exercise. Unfortunately, nobody really knows when the proper time to take these antioxidants so as not to interfere with the exercise-induced benefits. I've written to some researchers. They were not able to give me an answer because nobody's researched this yet. However, I suspect that if you want to take antioxidants, it's probably best to take them about 2 hours after a workout. So wait at least 2 hours before you take an antioxidant like vitamin C, E, or NAC. Interestingly enough, though, some earlier studies show that NAC helps increase muscle recovery after training. It helps reduce muscle soreness, and it increases the rate of muscle recovery. Again, I would suspect that this is related to the fact that it's readily converted into glutathione. So that's about it for glutathione. Again, the take-home message: don't bother wasting money on glutathione supplements. If they're included any product that you're already taking, such as a pre-workout or any like that, don't worry about it. It's not going to really hurt you, but it's useless. The only real good source of glutathione is NAC or cysteine, or the amino acid cysteine itself. But NAC is a really readily available source of cysteine, which will be immediately converted into glutathione in the liver. So again, that's about all you really need to know about glutathione. I have a lot more information on supplements, nutrition, ergogenic aids, hormonal therapy. As I said, in one of the next upcoming issues of Applied Metabolics, I'm going to have the most in-depth article ever written for the lay public on the effect of anabolic steroids in the liver. I'm going to have another article on the effect of anabolic steroids on kidney function, which is not many people know this. Very, very little has been written about that. I'm not going to talk about a lot of the other articles I have coming up because, it's a competitive world. There's other people that are publishing publications, and I don't want to give them any material to use because they're competitors. It's that simple. But I have other things. My newsletter is based on my 56 years of constant study and empirical experience training in the gym. I impart all the knowledge I've learned over the years into this newsletter. There's other newsletters, like I say, they cost twice as much money, sometimes 3 times as much money as my newsletter, and yet they don't contain even a fraction of the content I have. And even worse, some of these other publications are written in what I call medicalese. In other words, they're highly technical. They read like medical journals. They're very difficult to understand unless you have a science degree. My newsletter is written in plain English. Any technical terms I have in the newsletter, I will readily explain. So my newsletter could basically be understood by somebody who went as far as the 6th grade. So I strongly suggest you subscribe to my Applied Metabolics newsletter, I guarantee you will get some benefit out of every issue. It's www.appliedmetabolics.com today. I mean, appliedmetabolics.com. I was going to say subscribe today. Got ahead of myself. Also, I want to quickly add, I do have a email portal on my Applied Metabolics site. That's strictly for the use of my subscribers. They can ask me questions about anything I've written about. If they're not sure about something, they're welcome to send me an email. But it is strictly for subscribers. I don't answer unsolicited questions from people who are not subscribers. Also, subscribers get a invitation to my private Applied Metabolics Facebook page. Again, available only to subscribers. This page has additional material. I also answer questions on my Facebook Applied Metabolics group, and it has a ton. I mean, every day I put a ton of nutrition and medical studies that on that page that would be of interest to anyone involved in exercise, fitness, or anyone who just wants to keep in shape and stay healthy. And again, that's only for subscribers. I know that people often leave comments under my videos asking me questions about the videos, and I have answered some of them in the past. Unfortunately, I have to curtail that because I just don't have the time anymore. So I'm not going to be able to answer unsolicited questions left in comments under the video. I will only answer again questions submitted to me by subscribers because I appreciate their support of my newsletter, and I answer the questions as a benefit of their subscription. So I really don't have the time to answer unsolicited questions. So I'm sorry. I apologize in advance. You're welcome to leave comments under this video, but I'm sorry, I'm not going to respond to them, any of them good or bad. And if you want to have the best friend you'll ever have, go to your local shelter, adopt a dog. They're the greatest animals on earth. I don't know, I think I've had dogs for about 15, maybe 17 years now. And I really couldn't imagine even living without a dog. I just absolutely love them. They're the best friends you'll ever have. Take care.